Hello, students. This lesson is on energy flow diagrams. Energy is very dynamic. It doesn't stay from its stored form. It changes from one state to another state or one form to another form, depending on what you want it to do. But before you can get an energy flow, you will need energy converter. An energy converter converts energy from one stored form to another form. Okay, without the energy converters, energy cannot easily flow. Okay, so normally you start by drawing the stored name, what sort or how the energy is stored, and then you draw an arrow to show how the energy is being transferred, how the energy is flowing, and how and what type of energy converter you are using. So the energy will flow into an energy converter, which then converts it from its stored form to another form. Let's have a look at some few examples. Example number one, bulb connected to a cell. So you've got the cell, which provides electrical energy to the lamp. The lamp is the energy converter. What does the lamp do? It converts electrical energy into light and heat energy. On top of your screen, you see the circuit diagram. You have your cell, you have your switch. The switch is closed. The electricity from the light, from the battery or the cell flows into the light bulb. What does the light bulb do? It changes it into heat and light. So in the cell, there's chemicals. So we have chemical energy. That's a stored form of electricity is stored in chemical energy. When it starts moving, it changes from chemical to electrical. Then the lamp uses it, changes it into heat and light. And then the environment will experience what we call thermal energy, which is the same as light because of the heat. Let's look at another example. Now we've got a candle. What sort of energy is stored in a candle? Remember, candle is a fuel. We said in previous lessons that fuel are stored in the form of chemical energy. Every fuel has chemical energy. Okay, so the stored form is chemical, and then it is changed into heat energy and light energy, and it heats the environment. So it's called thermal. The environment will be hot, so the environment will have a thermal energy. Well done. Let's look at this one. A car is accelerating, okay? What makes a car work? Without that thing, the car stops. It's fuel. It's fuel. And every fuel stores chemical energy. Food and fuel are stores of chemical energy. Now, the chemical energy is transferred or changed or flow in the form of electrical energy. So the engine uses the petrol or the diesel, which is a chemical energy, and changes it to electrical energy, which goes into the motor. Now the motor moves, so it's mechanical or kinetic, and then it also produces heat, and then you get heat energy coming up. Now, let's look at motor lifting a weight. A motor lifting a weight uses kinetic energy. It uses kinetic energy. The kinetic energy is changed into electrical energy in the motor. The motor is the energy device or the energy converter. Any device that uses energy is called energy converter because basically it's using the energy and changing it from one form to another form. So now we're going to get a gravitational potential energy because the object is going up, so it's gaining height. And then at the same time, because of the friction, we're going to get some heat energy. Okay, let's look at a catapult. A catapult stores elastic energy. A catapult stores elastic energy, and the catapult is made from materials or it's made from chemicals. So the chemical changes into elastic potential energy. When the catapult is fired, then you get elastic potential energy being changed into kinetic energy. Okay, so the energy stored in a catapult is elastic potential energy stored in the catapult. Okay, now we're going to talk about a pendulum. A pendulum is any object that's moved to and fro, and as it moves, it tends to dissipate energy. So after some time, the pendulum will not have enough energy to make it move. Now, pendulum, it starts up with chemical energy in the muscles, or it could be chemical energy in anything. Then it starts moving, which is mechanical or kinetic. When it shrinks down, you get gravitational potential energy being changed into kinetic energy. And when it shrinks up, then you get kinetic energy. You get kinetic energy being changed into gravitational potential energy. Okay, brilliant. Let's look at this example. Now we've got gravitational potential energy store. When an object is thrown in the air, the object slows down as it goes up because of the force of gravity. And when it gets to a certain height, the object attains or gains gravitational potential energy. As long as that object is up, the object has stored some gravitational potential energy. When the object starts falling back, it loses it, and then it gains kinetic energy. Okay, so that is the energy transfers. Okay, when it hits on the floor, it makes noise. There'll be friction between the ball and the surface. Okay, so there could be some couple of videos that we can watch to understand this better, but I think you pretty much understand that. Now we're gonna look at let's look at this one, the match. Okay, right, so we're gonna end here. You can watch the videos by yourself, and these are the links. You can get the video and watch it. They are very useful. So to sum up what we've done today, we looked at energy flow diagrams. Energy flow diagram should have an energy converter. It should have a flow. We use that arrows to show the flow. It shows the direction in which the energy store is flowing towards. And it also has output energies. The output energy is the energy that we get after the energy converter has used the energy. Okay, so you need to know different examples. When any object is moving up, it is gaining gravitational potential energy. If it's falling, it is gaining kinetic energy and losing gravitational potential energy. Okay, any questions, you can leave a message and I'll get back. Thank you very much. Bye.